All right, today we are diving deep into something really cool, the engine room of decentralized prediction markets. We're going to break down the Gnosis Conditional Tokens framework. I know it sounds a bit technical, but this is the tool that lets basically anyone build complex prediction markets right on the blockchain.
So the big question is, how do you actually do it? How do you build a system where anyone, anywhere, can bet on some future event, like an election or a stock price, and do it without having to trust some central company to hold all the money and pay out the winners? That's the puzzle we're going to solve today.
And don't worry, we've got a clear roadmap to figure this all out. We're going to start with the basics, like what even are conditional tokens? Then we'll walk through the whole life cycle of a digital bet, step by step. And finally, we'll get into the real secret sauce that makes this whole system so powerful, something called bit masks. So, let's dive in. Okay, first things first. What exactly are we talking about when we say conditional tokens? Let's define the fundamental building block here. So, at its core, a conditional token is just a special kind of crypto asset. The best way to think about it is like a digital claim ticket. But here's the catch. This ticket only has value if a very specific thing happens in the future. It's basically the digital version of a bet. Okay, so we have these building blocks. How do we actually use them to create a market? Well, it all starts with a question. And to make this super clear, we're going to use a simple example throughout this whole explainer. Here's our question. Will the price of Bitcoin be above $70,000 at 12 UTC on November 1st, 2025? Super simple, right? This gives us two very clear potential outcomes. Yes, it will be, or no, it won't. Now, for any market like this to work, you've really got three key players. First, there's the market creator. That's the person who actually sets up the question. Then you have the oracle, which is a super important trusted source that's going to report the final real-world result. And of course, you've got the users and traders, the people who are actually placing the bets and making the market move.
So the very first step on a technical level is for the market creator to call a function on the smart contract called prepare condition. Think of this like setting up the scoreboard before a big game. You're defining the question, you're pointing to who the referee, or in this case the oracle, is, and you're saying how many outcomes are possible. But notice, no money has moved yet. We're just setting the stage.
And this line of code here really shows what's happening under the hood. The smart contract basically creates a little scoreboard for the payouts. Since our question has two outcomes, yes and no, it makes a list with two spots. And right now, as you can see, they're both set to 0. The game is all set up, but the score is 0-0. Nobody knows who's going to win.
All right, the market is officially set up on-chain. Now for the fun part. Let's move on and see how people can actually get involved and place their bets.
This is really where the magic happens. Let's say a user, we'll call her Alice, wants to participate. She takes 100 DAI, that's a stable coin, so think of it as $100, and she locks it into the smart contract. To do this, she calls a function called split position. The contract takes her 100 DAI as collateral, and in return, it mints her a complete set of outcome tokens. She gets 100 yes tokens and 100 no tokens.
And this table makes it super clear what just happened. Alice's DAI balance went from 100 down to 0. That 100 DAI is now sitting inside the smart contract. In exchange, her wallet now has 100 yes tokens and 100 no tokens. Now, this is the key part. She holds a full set, both sides of the bet, which is backed by her original $100. From here, she could, say, sell all her no tokens to someone who thinks Bitcoin won't go up. And just like that, a market is born.
So now you've got traders buying and selling these yes and no tokens. Their prices are going up and down based on what people think is going to happen. But that can only go on for so long. Eventually, the date arrives, the clock runs out, and it is time for the moment of truth. So, November 1st, 2025 rolls around, and let's say Bitcoin's price is $72,000. It happened. The yes side was right. Now, that trusted oracle we mentioned earlier, it's their time to shine. Their job is to look at this real-world fact and report it back to the smart contract.
And here's how that real-world event gets translated into blockchain language. The oracle calls a function called report payouts. It passes in this little array, 1, 0. Now, what does that mean? It's simple. It tells the contract that the first outcome, which was our yes outcome, gets 100% of the prize pool, and the second outcome, no, gets 0. The final score is locked in. Yes wins.
Okay, so the market is resolved. We have a clear winner. Now for the part everyone cares about, cashing out. Let's see how the winners actually claim their prize.
Remember those yes tokens?
Well, they've just transformed from speculative assets into winning lottery tickets, or more accurately, winning claim checks. Anyone holding them can now call the redeem positions function and trade those tokens back to the contract to get their share of all that DAI that's been sitting there as collateral.
And just like that, the value of everything becomes crystal clear. Each Yes token is now worth exactly 1 DAI, and each No token, it's now worth, well, 0. It's a dud. The entire prize pool gets paid out to whoever was holding the Yes tokens. The whole thing worked from start to finish without needing a central company to do anything.
Okay, so that was a pretty simple yes versus no market. And that's cool. But what makes this whole framework really powerful, I mean, a total game changer, is how it handles much more complex situations. And this is where we get into the real secret sauce of the whole system, something called bit masks.
So you might be thinking, wait a minute, why does the contract use numbers like 1 and 2 for the outcomes? Wouldn't it be simpler to just use, I don't know, yes and no, or maybe 0 and 1? And that's a great question. There's actually a very, very clever reason for this.
The short answer is flexibility. You see, using simple integers is easy for us to read, but for a computer it's kind of rigid. Instead, this system uses what are called bit masks. Each possible outcome gets assigned a power of 2, so 1, 2, 4, 8, and so on. Now, this seems a little weird at first, I get it, but it gives these numbers a kind of superpower. They can be combined, almost like Lego bricks or puzzle pieces. Let's make this concrete. Imagine a different market, like an election with 3 candidates, Bob, Alice, and Carol. Instead of just numbering them 0, 1, and 2, we give them these power of 2 bit masks. So Bob gets 1, Alice gets 2, and Carol gets 4. If you look at those numbers in binary, you'll see the magic. Each one is in its own unique slot. They don't overlap. And this is the magic trick. Because each one has its own unique place, we can combine them without any confusion. Let's say you want to bet that either Bob or Alice will win. You can create a new, special token for that outcome just by adding their bit masks together. So 1 plus 2 equals 3. This new number, 3, now represents the outcome Bob or Alice wins. This is huge. It means we can create brand new tradable assets for all sorts of complex combinations, and the smart contract handles it all perfectly. This is the core idea behind what people call combinatorial markets.
So let's just leave it with this thought. If this system lets us take any combination of outcomes and turn it into its own unique, tradable asset, think about what that means. We're going way beyond simple yes or no questions. What kind of incredibly complex, layered, maybe even interconnected prediction markets and financial tools could you build on a foundation like this? The possibilities are pretty mind-blowing.